Welcome to the tutorial of Applied Statistics for Business. In this tutorial, we are going to talk about the one sample hypothesis test, in which we are going to talk about different hypothesis tests when we have one sample and we are going to test different hypotheses. After introducing the z-test, t-test, proportion test, and variance test, we will conduct these tests practically in the Minitab software, which is really powerful software for doing your statistical problems in your business. And one sample hypothesis test is a statistical method used to determine whether population parameter such as the population mean or the population proportion or variance is significantly different from the hypothesized value. It involves comparing the sample data from a single group to a known or hypothesized value. As you know, in the hypothesis testing, we have the null hypothesis, which states there is no significant difference between the population parameter and the hypothesis value in the one sample hypothesis test. Furthermore, we make a decision based on a comparison between the calculated statistics and significance level. Here in our tutorial, we consider a 5% significance level, which is often noted as the alpha equal 5%, and it is commonly used as a threshold in hypothesis testing in order to determine whether the results of a statistical test are statistically significant or not. In a way that if the p-value, the actually probability value from the test is less than or equal to 5%, this means you would reject the null hypothesis in the favor of the alternative hypothesis. So if the p-value is greater than 5%, you would fail to reject the null hypothesis. We will investigate different hypothesis tests by considering this rule in order to decide whether to reject the null hypothesis or not. The first test which we have here is z-test and t-test. Let's start with t-test. As you can see, this is the statistic for t-test. We use t-test in order to test whether the mean of single sample is significantly different from a known or hypothesized population mean. For example, imagine that a researcher wants to test if the mean score of a group of students on a test is significantly different from the national average score. And the z-test is similar to the one sample t-test, but it is used when the population standard deviation is known. As you can see, in the formula of z-test, we have sigma, which is known. However, in the t-test formula for its statistic, we have s, which is the estimation of this sigma. As in reality, in a project which we have, we usually don't know what is exactly the standard deviation of the population. We always use the t-test statistics in order to analyze the null hypothesis which we have. As you can see, there are three different hypotheses, and in all these three, the null hypotheses are the same, which we are going to see whether the mean of our sample is equal to a specific value or not. And the point is that the software which we are going to use is Minitab, and as the output of each hypothesis test, it gives us the p-value, which we can compare the p-value with the 5% significance level which we want to consider for different projects. Another test which we have, it's for the variance of our population. The one variance test, also known sometimes as the chi-square test for variance, is a statistical test which we use to determine whether the variance of a single sample differs significantly from the hypothesized population values. For example, maybe a researcher wants to test whether the variance of the height of a sample of individuals is significantly different from a known population variance or not. By conducting these variance tests, we can conclude that can we reject the null hypothesis or not. As you can see here, the statistics which we use is the chi-square, and these are the confidence interval for rejecting or accepting the null hypothesis. However, we always use the p-value which we calculate from this statistic, and then we compare that with the 5% significance level in order to decide whether to reject the null hypothesis or not. The next statistics which we are going to explain in this tutorial is the proportion test. We use the proportion test to test whether the proportion of a success in a single sample is significantly different from a known or hypothesized population proportion. For example, it can be used to determine if the proportion of defective items in a manufacturing batch differs from a predetermined value or not. As you can see here, we have the Bernoulli distribution for our data. This can be a success of an event within a data set, and we want to test the hypothesis whether the proportion is equal to a specific value or not. And since in the Bernoulli we have the variance of p multiplied to 1 minus p, we use this statistic. Now it's time to see how we can conduct these different statistics on the real data set in Minitab. As I stated earlier, we use Minitab software, and here is the general overview of the Minitab software. As you can see, here we have our data set. We use a sample data set in which we have the column called ID, age, sex, children, house, region, and cost. We are going to conduct different hypothesis tests on this data. Minitab is really powerful software for doing your statistical purpose for your business, and since it is really user friendly and you need no knowledge of coding, I suggest you to use in your business. Of course, we have a separate tutorial for Minitab in which we cover different options of Minitab which you can have on your data, from descriptive statistics to predictive statistics which you have. Now in this tutorial, just we want to focus on different hypothesis tests for one sample data as I explained you. Let's start with z-test and t-test. This is the column of age. As you can see, imagine that we are going to test the hypothesis in terms of the average of the age for the population which we have. This is the sample data, and we want to infer different insights from this sample for our population. I want to test whether the average of age is equal to 30 or not. Since I have the sample of my data, I can conduct this hypothesis. In order to conduct different hypotheses in the Minitab, you should come to the Stat tab, and here we have the basic statistics. In the basic statistic, as you can see, you have different options, which we will cover all these options in tutorials of statistics. Here, you see one sample Z and one sample T. As I told you, the difference between one sample Z and one sample T is that when you want to use the sample Z, you should know the standard deviation of your population. Since in most cases we do not know what is the exact value of the standard deviation of our population, we usually use the one sample T. But let me show you the difference between these two statistics when you click on one sample Z. As you can see, when you click on one sample Z for the mean, here there is option in which you should enter the standard deviation of your population, because you are using the Z statistics in which one of the input value was the standard deviation of your population. And if you do not have this parameter for your population, you should use the T statistic. So I come here, basic statistics, and here I click on one sample T. And here, as you can see, now you are not forced to enter the standard deviation of your population because it is unknown for us. Here I should choose which column I want to test this hypothesis. I click on age, and since I want to test whether the average age of the population is equal to 30 or not, I click on OK. And after that, here some calculations are actually calculated for me. There is a descriptive statistics table, and here there is a test. It is apparent that the null hypothesis is when the mean is equal to 30, and since the p-value is equal to 0 and it is less than the 5% significant level, we reject the null hypothesis, which means the average of age for our population is not equal to 30. As you can see here, we have one parameter which is calculated for this sample, and here it is stated that the mean is around 40. And of course here we have the confidence interval in the 95% confidence level, which is between 38 to 40. In other words, a representative that in 95% of situations the average of the age would be placed in this interval. However, our hypothesis was about the 34 average, so we reject the null hypothesis in the favor of the average, which is not equal to 30. Let's do another hypothesis test for the variance of age. In order to do the hypothesis for the variance of age, you should come here again, and as you can see, there are other options for your hypothesis test. Here we have one variance, which is for the variance or standard deviation of your population. I come here and again I click on age. I want to perform a hypothesis test. I want to test the hypothesis that the standard deviation of the population is equal to 10 or not. Here you can change the standard deviation to the hypothesized variance if you want. And of course here we have option, and in the option you have those three kinds of hypothesis which you could have. All these three are the same in terms of null hypothesis. However, the other hypothesis would change in terms of the two-sided or one-sided, which you prefer. In our tutorial, we consider that we want to two-sided hypothesis. I click on OK, and after that, on OK. And here we have that hypothesis. In our hypothesis, as you can see, here the chi-square has been calculated, and the p-value of that is equal to 0, which means again we reject the null hypothesis in the favor of the other hypothesis, and the standard deviation of this sample has been calculated 14, which we have the confidence interval between 13.5 and 14.6. So since our hypothesized value is not in this interval, we cannot accept the null hypothesis. And as the last hypothesis, we want to see about the proportion of our customers in terms of owning houses or not. Now we want to conduct the proportion test for this house. We want to see whether the proportion of those customers who owned house is equal to 20% or not. Let's see how we can conduct the proportion test for house variables. The proportion test is again in the same path as that, basic statistics, and here we have option 1 proportion. We click on 1 proportion and we click on house. We want to see whether the value of the proportion for those customers are equal to 20% or not. So I choose 0.2 and then I click on OK, and here, as you can see, the null hypothesis is when this proportion is equal to 0.2 and the p-value which we had is above the 5%, and it is estimated that the confidence interval for this probability is between 18% to 22%. And since we have 20% in the null hypothesis, our p-value has been calculated 0.6, which is above than 5%, and we cannot reject the null hypothesis in which we have the 20% of our proportion. So you learn how to conduct different hypothesis tests in Minita. Let me overview what we learned in this video. We learned that if we want to conduct different hypothesis tests when we have one sample, we come to in the stat tabs, basic statistics. If we want to test whether the population mean, we choose the T, sample T. However, in some specific circumstances, if you know the standard deviation of your population, you can choose the sample set. For the variance, we use the one variance. For the proportion, we use one proportion. In upcoming videos, we will delve into two sampled hypothesis tests.